Hello, Tom, again from Every Step Calculus, everystepphysics.com. Physics problem, you can see on the screen here, trying to find the force of gravity on a satellite when they've given you the mass and the period of its orbit. So let me show you how that works in my programs. Physics to get to my main menu. I'm already at planets. You scroll down there yourself if it comes, because it starts at the beginning of the alphabet A. You scroll down to P, where it's planets, anything to do with any of this stuff, you know, Jupiter, moons, or planets, or satellites, or probes. You go to my menu for planets, okay? And then up comes this menu here, and we want to find the force, number 8 force on the satellite. Gravitational force on the satellite, okay? And so we're going to press number 8. When it's busy here, it's loading the first time for the simulator here. Gravitational force on a satellite circling the Earth, okay? Now I give you what they've, there's several different things that they give you for this question, and in this case it's mass and period, so we're going to choose number 1, and we're going to enter the mass of the satellite, and that's 5,500 kilograms. We're going to press alpha first, alpha 5500, press enter, and choose number 2 kilograms. Enter the period of orbit, okay? The period is given as alpha 6200, and that's seconds, number 2. I always show you what you've entered. You can change it if you want. Say it's okay. I give you the gravitational constant, which is needed. I give you the radius of the Earth, which is needed. I give you the mass of the Earth, which is needed, okay? In this problem, they say it's 6 times 10 to the 24, and the real thing is 5.97 e to the 24, okay, kilograms. But you can use 6. Once you do this, you can use 6 if you want in the calculations and do your own calculations. But so now we do the formula. Here's r cubed equals gm, gravitational constant, and the mass of the Earth, and the t, the period, divided by 4 pi squared, okay? So we enter the variables, and we come up, do the calculation, we come up with 3.8785 e to the 20 cubic meters, all right? Now we have to do the cube root of that, so we take that answer and cube root it, which you can do with the exponent of 1/3, same thing. Comes up with 7.2927 e to the 6 meters. That's the orbit of the satellite, the radius of the orbit. From the center of the Earth to the satellite, okay? Make sure you understand that in planets. Sometimes I'll give you surface, and that's not the radius, okay? You need to add the radius of the Earth, because everything needs to go to the center of the planet. So Fg is the gravitational force, or the force of gravity. And here's the formula right here. And we add what we've been given, and then we add what we figured. Come up with 41,194 newtons. That's the answer. All right, pretty neat, huh? everystepphysics.com. Go to my site, buy my program for $30. You can't go wrong, and you won't even notice the money because you have these fabulous things in your calculator. So anyways, good luck with your classes, and have a good one, okay?